So I want to talk a little bit more about open versus closed systems. And so we're going to start off looking at this odd shaped skate track as a closed system. And so what that means is that the total mechanical energy needs to be conserved. So if we play this out, what's going to happen is if the total energy is going to be conserved, you're going to see an exchange between potential and kinetic energy as this skater goes up and down the ramp. Okay, when they're up high, we have potential energy. As they go down, it transforms into kinetic, and it's just interchanging back and forth. Okay, and this would be a closed system in that the total energy of that system, total mechanical energy, would be conserved. Now, if we add friction to this system, it will become an open system, which means that energy will be lost. And so what's going to happen is some of this potential energy, and it kind of goes like this: potential energy is transforming into kinetic energy, and then some of that kinetic energy will get transformed into thermal energy, which then gets lost forever. Thermal energy is energy that is gone forever in the form of heat. We can't get it back. Okay, it goes to warming up the environment. So we're going to add a little bit of friction here, and suddenly you can see energy turning into thermal energy. And if you watch carefully, you'll notice that the places where it gets biggest, where there's the biggest transformation to thermal energy, is on these little turns here, is when the most thermal energy is created. Okay, so we restart the skater. Okay, at the beginning there was no thermal energy, we haven't increased the thermal energy yet because there's no kinetic energy yet. And as it goes back and forth, the friction between the skateboard and the track is going to cause thermal energy to be created, and you'll get to a point where you no longer have enough energy to get past this hill right here. Okay, because you have this much energy here, so you should be able to cross this hill and get all the way up to the same height over here. But you get to a point where you only have enough energy you get kind of trapped in this area right here, or trapped in this area. And we call those places where you can get trapped, we call those wells. Okay, and we'll get more into wells in kind of the next section. But let's watch it, okay? So thermal energy is increasing, especially on these turns it increases. And at some point, we're not going to make it over the hill anymore, and we get trapped in this well here, just going back and forth, losing energy, losing energy, losing energy. Okay? And that's basically the difference between an open and closed system. In that closed system, you're going to have no friction, and you'll just keep going forever back and forth. In the open system, we have friction, and so we lose energy to thermal energy, and energy is leaving and can also enter the system. Unfortunately, in this simulation here, we can't put energy back into the system by giving like the skater a push or something, because theoretically, if you gave the skater a push, you could do work and increase the kinetic energy of the system, but it doesn't let you do that here. So anyway, I hope that made sense and was helpful, and hopefully you're kind of starting to understand how open and closed systems work.